So laser part we have completed. Now I will move to wave optics part of module 4. Wave optics. This is very interesting topic. Okay. So as you are familiar with this wave optics and ray optics in the lower class also. So what is optics? First you should know is the branch of physics that deals with study of light and various phenomenon related to it. So what are the various phenomenon? It may be interference, of light, diffraction of light. There can be reflection of light, refraction, etc. So these are the meaning of optics. So here we'll understand the wave optics, not ray optics. So first of all you have to learn about what is interference of light. So we define like this: the modification in the intensity of light where it is maximum at certain point and minimum at certain other point, called as interference of light. Let us say, so this is the screen is there, and on the screen this is the bright point we say, and this one is dark point. Dark point. Further this side also dark point. So and further there is a bright point, this side also as well as this side also. So what is this alternate? We can say bright, dark, bright. So this is called as what? Interference pattern on the screen. Here the intensity is what? Maximum. Intensity is maximum. Here intensity is what? Minimum. Further intensity is maximum, and further here intensity is minimum, and so on. So maximum, minimum intensity in the region of superposition called as interference of light. It is of two types. Two types are there. First one, constructive interference. In short, I can say CI. For constructive interference, there is a one condition: path difference should be an integral multiple of lambda, n times lambda, where n can be 0, 1, 2, 3 and so on. So it can be 0 or 1 lambda, 2 lambda, 3 lambda. At each and every this path difference, constructive interference will take place. And phase difference is also there. Phase difference in terms of pi should be equal to 2n pi, where n further it is equal to 0, 1, 2, 3 and so on. That is, we can say phase difference should be 0, and this can be 2 pi, 4 pi and so on. There is even multiple of pi, and here all integral multiple of lambda. So pi multiple phase difference and lambda multiple path difference. Now we'll see that destructive interference, how this is different. For destructive interference, this will differ. Destructive interference, just opposite conditions. So second type, destructive interference. So this is, in short, I write DI, destructive interference. So what happens in destructive? Path difference should be an integral multiple of half the wavelength of light, 2n plus 1 lambda by 2, where n is equal to 0, 1, 2, 3 and so on, or it can be equal to 2n minus 1 lambda by 2, and if I am writing minus, and value start from 1, 2, 3 and so on. So that is what will come if I will substitute 0. So 1 lambda by 2, okay, then there will be 3 lambda by 2, 5 lambda by 2. At all these points destructive interference will take place. Whereas phase difference, if we talk, phase difference will be equal to 2n plus 1 times pi, where n is equal to again 0, 1, 2, 3 and so on, or it can be 2n minus 1 times pi, then n value starts from 1, 2 and 3. Okay, so that is what phase difference will come. 0, if I will keep the 1 pi, and there is a 3 pi, 5 pi and so on. There is all odd multiple of pi will produce the condition of destructive interference. Now what is the relation between path difference and phase difference? So there is a relation with one formula between path difference and phase difference. So phase difference equal to phi, it is denoted by phi, is equal to 2 pi upon lambda into path difference. So this you have to remember for the numerical as well as for the derivation. Okay, so phase difference phi, path difference can be by delta. Let us say it can be represented by delta, path difference. Okay, thank you.